Hello, Calc. It is February 10th, the year 2017, and 39 years ago, I was in labor delivering my first baby. And so, this is a good day of good memories for me. So, we'll continue our good memories by looking at this review work. This review is aimed at Thursday's test. We're going to test on Thursday. Monday will be a review day. Tuesday will be out of the city. We'll be in Philadelphia. And then on Wednesday, we'll complete our review, practice problems, and Thursday we'll test. Here are the topics that will be on the test. Be derivatives of inverse functions, logarithmic differentiation, derivatives of logarithms and exponential functions, Newton's method, inverse trig derivatives, and integration. So that'll keep us busy for a while. All right. The newer things that we learned about left and right boxes areas under a curve or the planar area of a planar area is going to not be on this test. All right, I'll start reviewing with, I'll take a function and we're going to find the derivative of the inverse at a certain point. So let's take the function f of x equals x cubed plus 2x minus 1. Sorry, my pen squeaks. I want to find the derivative of the inverse. At x equals 2. All right. So first of all, you want to establish, it's a 3 by the way, you want to establish whether that does have an inverse or not. So the function x cubed plus 2x minus 1, you would take a look at the graph of that, and I'm pretty sure that it's always increasing. So you want it always increasing or always decreasing. So it'll pass both the horizontal and vertical line test, and that's called monotonic. That means it's always increasing or always decreasing. It's always in the same direction. You can also take the first derivative and see if it's always positive. That's the idea we'll talk about. So the derivative is 3x squared plus 2. Do you see no matter what number I put in 3x squared plus 2, it will always be a positive number? It will. So you know then that it's always increasing, and therefore we can find the inverse. So establish that, and then we learned that the derivative, well, let's just suppose that our regular graph looks like this. It does not, but let's suppose it does. Then the inverse would be a reflection across the y equals x line. So it would look like this. So if this is f of x, then this is f inverse. And now we are looking at this derivative of the inverse at x equals 2. So that means somewhere on the inverse function, the value of 2 appears. So 2 as the x value on the inverse means that it's the y value on the original function. So it would be helpful for us, since we're gonna get the derivative of this without looking at the actual inverse function, we're going to use a little trick of our trade by taking the derivative of this and recognizing that the slope here and the slope here are actually reciprocals of one another. So if this is 1/2, this would be, or if this was 1/2, this would be 2. So they're always when you have inverse functions, their derivatives are reciprocals. But the tricky part is knowing what value to put in. So I know I'm going to find the derivative of this and look at its reciprocal but what I will not be putting 2 in there because 2 is the x value on the inverse, and so I'm going to need to find the x value on the actual original function. So the way I do that, I know that it's the y value, so I'm going to replace f of x with 2. So again, 2x on the inverse is going to be y on the original. This is the original. This stands for y, so I'm putting the 2 there. It's going to equal x cubed plus 2x minus 1. And if you recall when we did these, we always know that it's a simple answer. We're not going to go into solving a cubic. We're just going to assume that the answer by inspection will be possible to find. So usually it's like at the most -3, -2, -1, 0, 1, 2, or 3. So looking at this, it looks like it's 1. So I'm going to put in a 1 for x and see if that gives me 2. It does. So I solved it, and x equals, the x value equals 1. So therefore, I'm going to put that there. It's also the y value. I don't need to know that, but it is the y value on the inverse function. So here's the important part right here. That is what I'm going to plug in. So I'm going to take this function, make a reciprocal, find the derivative. It's 3x squared plus 2, and evaluate that at the x value of 1. I get 1/5. That is the answer. All right, so hopefully that brought back the skills that we had previously, and I'll give you some to practice on Monday in that category. We'll also review logarithmic differentiation. Here we are reviewing the last part for tonight, and that is the derivative of expressions with logs and exponentials. So here's an exponential, e raised to the u. Well, then y prime is e to the u du dx. And so if it was e to the x, it'd be e to the x. It'd be its own derivative. But if u is an expression in x, it must be followed by du dx because of the chain rule. All right, so then y equals ln of u, which is an expression in x. Y prime is 1 over u du dx. So that's the when you have a natural log. So let's upgrade. What if we don't use e here, but we use a? Y equals a to the u. The difference here is a factor of ln. So a is a number like 3 to the x or 3 to the 4x. So when you have something like that, it's going to be similar to this in that you're still going to repeat a to the u, but there's going to be a factor of ln of a in front of it. And then du dx. All right, and then we'll look at this one. When it's ln means base e, so I'm going to look at a different base, like log to the base b, some base b. How did I say that? I think I said log to the base a. So let me stick with that. All right, so log to the base a of some expression u. Again, an expression in x. Y prime is similar to this. It's 1 over u, but there's another factor, and that factor is ln of a. So that tags along when the log is to a different base other than e. All right, so followed by, of course, du dx. All right, can we use those to do a problem? Let's just look at one. Y equals 6 to the 2x. So y prime, so in this case we're following this rule right here. So a to the 2x, y prime is going to be ln of 6 times a to to the 2x, 6 to the 2x times the derivative of u, which is just 2. So putting that into a pleasing order, I'll just have a 2 ln of 6 and a 6 to the 2x. All right. I guess I should do one logarithmic one. I'm not sure if I have any more board space here, so in your view. So you can pause that and get that down if you need to. Give myself some working area. And that is, say I have y equals ln of, let's be brave. Let's do another log. Let's do log to the base 4 of x squared plus 3x plus 1. All right, so with that one, we can use this rule. So y prime is going to be 1 over ln of 4 times the expression x squared plus 3x, all this in the denominator, times the derivative of that, which will end up being in the numerator, the derivative of that expression, 2x plus 3. All right, that is part of our review, so we'll work on those skills on Monday and get you all ready, ripe and ready for the test. So we'll see you then. Have a good rest of your weekend. Bye.